Hi there, this is Dr. Satish, Assistant Professor at British Applied College. I welcome you all to this video lecture. This is for ENG208 Mechanical Principles, Level 4 Pearson Higher National Diploma students. Now, in this video lecture, we will be looking into an introduction to shear force and bending moment diagrams. Now, when I say about shear force, this refers to unbalanced vertical forces either on the left or right side of the beam. For example, if I draw a beam, okay, so let me draw a beam. This will be my reaction forces. If this is the load acting 2 kilonewton, then the shear force diagram will look like this. As an introduction, I'll show you the shear force diagram, then later I'll tell you the rules to draw the shear force diagram. So this will be what the shear force diagram will look like. So if I take at any position, for example, if I take at this position, okay, then this refers to unbalanced vertical forces on the left or right side. So this is what is called as shear force diagram. And the bending moment diagram, it refers to the summation of moments, okay, either on the left side or on the right side of the beams. Okay, so my bending moment diagram will look like this. Okay, so this is my positive shear force section, negative shear force section, and this is my positive bending moment. So this is how bending moment for a simply supported beam will look like. This is my simply supported beam with a point load. Now let me describe the rules for drawing the shear force diagram and bending moment diagram. When it comes to shear force diagram, if you want to draw the diagram from the left to the right, okay, if you want to draw the diagram from the left to the right, then you can follow this rule. Okay, so the force is acting, let me write here, shear force sign convention. Okay, so if I move from the left of the beam to the right of the beam, if the forces are acting in the upward direction, then I will consider them as positive sign. Okay, this is the rule which I move from left of the beam to right side of the beam. If suppose the forces are acting downwards, then obviously it will take a negative sign. Now if I move from the right side of the beam to the left side of the beam, then the upward forces will be considered as a negative sign and the downward forces will be considered as a positive sign. Okay, so you can follow either one convention. I personally follow always I move from left side of the beam to the right side of the beam, so I can easily remember all the forces that are acting upwards positive. Okay, so this will be easy for you, but you are free to follow any sign convention. Now if I go to bending moment, if I want to write about bending moment sign convention, then please remember this is my sagging bending moment. Okay, this is called as sagging bending moment, which is called as positive. Okay, and this is my hogging bending moment, hogging, and this is called as negative bending moment. So see the left and right side. Okay, so on the left side of the beam, if it is creating a clockwise, okay, so this will be considered as a positive. Fine, please remember this will be considered as a positive sign. If on the from the right side, if it is creating a anti-clockwise, then it will be considered as a positive. From the left side of the beam, if it is creating a anti-clockwise, then it is considered as a negative. From the right side of the beam, if it is creating an anti-clockwise, then it is considered as a negative bending moment. Okay, so I hope you understood this part. And when you are drawing bending moment diagrams, the slope, okay, whether it is positive or negative, it depends upon the shear force. Okay, if the shear force region is positive, the bending moment slope will be positive. If the shear force is negative, the bending moment will be negative. See, look into this figure. See here. So this is in my positive region. So see the slope. The slope is positive. Okay. Now see this slope. See, this is a negative shear force. Okay, the region is negative. So see the slope. The slope is negative. So this is how we draw the bending moment diagram. Now I am going to write a table. I am going to show you a table. Let me show you a table. So this is a table where you can see, okay, the load, the type of load. Okay, the type of load is connected to the shear force diagram and a bending moment diagram. Here this table shows the point load. If you apply a point load, then the shear force diagram, okay, you have to draw a horizontal line. Okay, and if the bending moment diagram will be linear. If it is a uniformly distributed load, then the shear force diagram you have to start with linear and the bending moment should be second degree parabola. For example, imagine here. Let me go to the, okay, for example, if I have a simply supported beam, okay, with a point load and a simply supported beam with a uniformly distributed load, then for these cases the shear force diagram will look like this. The shear force diagram will obviously look like this. Here in this case, okay, my shear force diagram will, I'm sorry, positive. This is how my shear force diagram will look like. Okay, so this is my positive region, negative region, positive region, negative region. So, and if I go further to draw, so if you refer the table, you will understand this. See, when it is a point load, when this is a point load, when this is, I'm sorry, when this is a point load, the shear force diagram should be a constant line. When it is a UDL, it should be linear line. So if you see here, see, it is my point load, so I have drawn a horizontal line. See, I have drawn a horizontal line, but this is a UDL, so I have drawn a linear line. So this is how we proceed. Refer the table, you will be able to quickly draw the shear force diagram and bending moment diagram. This stands same for bending moment diagram as well. For example, if you see the bending moment diagram, the shear force should be constant, I mean horizontal line, and the bending moment should be linear. Okay, you can see this is a constant change and this is linear. Okay, if you see this table also says the same. See, this will be for a point load constant, bending moment will be linear. If I go further, for a uniformly distributed load, it will be linear second degree parabola. For a uniformly varying load, it will be second degree parabola. Shear force itself is second degree parabola. Bending moment will be third degree parabola. So these are the most important loads which you will be studying in Pearson. Okay, level 4. So don't worry about the final part. That's it from this video. Let me all see you in the next video. Thank you.